caution speed, pretty basic stuff. Kerry, just can I confirm that you're going to let people in as they start coming along if they're late? Okay, so yeah, let's give 2 more minutes and we'll get started at 6:05. That seems to be it. So let's go ahead. So what we're going to cover this evening, to a definition of position, caution speed. And when I say definition, there's about 20 of them. So it's kind of a rough overview of it. We'll talk about latitude and longitude and where it's derived from. And we'll talk about the knowledge of sort of standard navigational terms, wherein we're talking specifically navigation, not boat terms this time. We'll talk about the true bearings and true courses. We won't be going into magnetic at this stage. And then we'll talk about the knot, bit of history, and then what we use of it today. So, what are position, course, and speed? So basic ideas of that. Okay, so if you look in the bottom right-hand corner, this is shots that I've taken over periods of time of positions. Basically, where your position is relative to where you are on planet Earth. Okay, and it's relative versus everybody else. Okay, so this information allows you to navigate to fixed objects and other positions, known positions. It is not anything really relevant to other floating objects unless that is a fixed position is known. So we're talking about actual position, and it has nothing to do with collision or course or coal regs. It's not in any way, it's just where you are. What you do with that information is then up to you. Okay, so a course. It's the direction you are steering, taking into account current and tidal drift, which we call set and drift. So if you look at the picture, you can see where you want to go, and that's where you're heading on the green line. So what's the difference between the two? Okay, the difference between the two is actually pissing your crew off completely and utterly. Because if you get it wrong, you'll end up going miles down tide and end up having to make your way back. So not understanding the difference between what set and drift is versus your heading can really, really ruin your day, your club's day, your crew's day. Okay, so heading versus course over ground, which is what we're talking about. Where you're actually going and where you're pointing is what it's all about. So what the compass course of your vessel is your heading. So where your boat is pointing, where the bow of your boat is, okay, that is your compass course and heading. Okay, that is not your course over ground at all. It's nothing to do with how you're traveling. It's just where the front of the boat is pointing. Little picture here, front of the boat is pointing there. We might well be traveling there though. Okay, your course over ground is where you're actually moving with all those external influences, tide, current, wind, leeway. So you might be pointing 20 degrees off where you're actually going. So the difference is heading is where you're actually pointing the boat. Course over ground is where you're actually going. So all those internal, external influences on your boat are now included in your course over ground. Okay, so where your vessel is actually going. So, for example, if you're crossing a river you might be pointing upriver and going sideways across the river with the current. So your heading is where your boat is pointing upriver, but your course over ground is the sideways movement across the river. Speed has a similar thing. So the speed of your vessel, including any set and drift. So you've got a speed and you've got a speed over ground, SOG. So course over ground, COG, you see it here. Speed over ground, SOG. Very similar. Okay, i.e. knowing exactly how fast you're going both through the water and over the ground. Remember, if you're in a river and you're going with the stream, you're going to be going faster than the actual speed your boat's moving at. If you're going downstream, inversely, if you're going upstream, you're going to be going slower. The same thing happens at sea with current and tide. Okay, so speed, the speed of your boat. If you look here on this picture, the speed of this vessel is doing 0.0 knots. That's the speed it's moving through the water. However, speed over the ground, with including your external influences, is actually doing 1.3 knots. So the current on this photograph, the boat is not moving through the water, but the current is moving at 1.3 knots. That's the difference between speed and speed over the ground. So if you take it as an example of you running on a treadmill, you're running along at 3 knots, but you're not actually moving. You're staying on the same treadmill. The same thing can happen at sea. You're sailing at 3 knots, into 3 knots of tide, you are stationary. Your speed over the ground is 0, but your boat is still moving through the water at 3 knots. So speed is what your boat's actually doing. Speed over the ground is what your boat's doing in relation to the planet. Okay. With that basics, where do we derive our position from? I'm pretty sure all of you have heard of lat and long. It's a grid system placed on top of the planet. You can't find the lines out there, so don't look for them. Okay. Latitude is our horizontal rings. Longitude are vertical rings. The two together make a grid. Okay. Assuming, and this is an assumption, that everybody knows that a circle is 360 degrees. So if we take the planet and we assume it's 360 degrees because it's a circle, where do we get our latitude from? So if we split the planet down the middle, there we go. Take the center of the Earth as our central point, and we say that is 360 degrees. We take the middle line as 0, and we go 90 to the North Pole, and we go 90 to the South Pole. So in other words, we're not going to get a latitudinal reading of above 90 degrees. If you're standing at the North Pole, your latitude will be 90. If you're standing in England, your latitude's about 55. If you're down in Cape Town, it's around 34. So the one is 55 north, 34 south. Okay. Note that they're evenly split all the way around. Okay, so that's 10, 20, 30, etc. We take the same thing with longitude. We cut the world the other way. Start at the middle. So there's prime meridian or GMT. Runs through England, through the Atlantic and down. And we go 180 degrees around the one side and 180 degrees around the other side. Okay. What's quite important here is, firstly, you can get a reading of 180 degrees or 179 degrees. So it's 3 figures, not just 2 as in 90. Secondly, note that your longitude become closer and closer and closer as they go to the North Pole. So the distance between them gets narrower and narrower and narrower and wider as you go north or south. Okay, so when we refer to latitude and longitude, it's the two grids put together. Again, note that latitude is even. Longitude gets narrower and narrower and narrower, or wider and wider until you get to the equator. At the equator, the distance between latitude and longitude is even, but that's the only place on the planet where it's even. When we talk about latitude and longitude, we will always give latitude first. So you'll give your north-south reading first, then you'll give your east-west reading. Secondly, when we're talking about latitude, we will only depict it in 2 digits. So this will be 3 degrees north or south, or 55 degrees north or south. Okay. Note the 03. You want to write latitude and longitude always with 2 digits. You wouldn't just go 3 degrees. You would go 03. Longitude, you do with 3 digits. So you would go 003 or 147. Okay, it could be 103 one way or the other, or it could be 147 one way or the other, until you tell it north, south, east, or west. Okay, so when we're writing these, we always write them as 3 digits for longitude, 2 digits for latitude, and we'll always refer to latitude first, then longitude. Okay, we then break that down further, because obviously that's not terribly accurate. So we get more accurate by breaking it down further. Both latitude and longitude will have 60 minutes in them. So if that's 1 degree of latitude or longitude, it doesn't matter, and you can see sort of one tiny little degree, we put in then 60 minutes. Okay, so where I'm pointing now would be 50, if it's latitude, 55 degrees, arbitrary number. That would then be 22 here. There's your 25, there's your 30. That would then be described as 55 degree, 22 minutes. If it's longitude, it's still exactly the same. I've just given an arbitrary number of 032 degrees. 59 would then sit right at the edge of 60. You would never have either of them saying 5560 or 03260, because it would then be, if this happens to be 55, it would then go up to 56.0. Or inversely, longitude, if it's 032, it would go up to, and the next one on that would literally be 033 degrees, 0 minutes. So you would always bounce straight back to the start of your minutes. Okay, we then break down minutes further, and each minute is broken down into a decimal of 10. So if we look here, we've got 32 degrees. Okay, and then that breaks up, and there's 1 minute and decimals of 10 inside it, which is why we have these funny little squares on the side so that we can see them easily. Okay, longitude is broken up the same way with a decimal of 10. Now note, minutes are 60, whereas we then go into decimals of 10. Okay, 1 minute, one of these little minutes is equal to 1 nautical mile. Therefore, we have in 1 degree, 1 full degree, we have 60 nautical miles, because there are 60 minutes in a nautical mile. So one of these decimals is then 0.10 of a nautical mile. Okay, modern marine charts do not use degrees, minutes, and seconds. Please, guys, that has been, well, unless you come out of the dark ages, that's it. All modern marine charts use a decimal of 10. So we use degrees, minutes, and a decimal of 10. Nobody ever uses degrees, minutes, and seconds these days, except for very, very outdated charts or areas where there have been no new charts put in. Okay, we don't need to go beyond a decimal of 10. A decimal of 10 is 99% accurate enough, unless you're going into very, very, very fine areas where you're probably going to do visual navigation over any sort of navigation done that needs to be a decimal of 100 or a decimal of 1,000. Modern GPSs will give you a decimal of 3 that is beyond accurate, and it's unnecessary from a nautical navigational point of view. Okay, and don't panic about this. I know degrees, minutes, and decimals at this stage looks like it's a bit of a complicated subject. It becomes second nature very, very, very quickly. Okay, so here we look at the number. We've got 32 degrees, 06 minutes, decimal 5 north, 025 degrees. Note there's 3 digits, not just 2. 07 minutes and decimal 7 east. That would be how you would read a latitude and longitude correctly. Some people write the north and the east first. It makes no difference as long as there is that reference. Modern charts will have a WGS 84 positions somewhere marked on it. It'll be on the edge somewhere like this one. Okay, it means exactly that. It's degrees, minutes, and a decimal of a minute. So if you're using a GPS, you must make sure that it's set up for WGS 84, because 90% of GPSs will still do degrees, minutes, and seconds. But that means you're not using a decimal of a minute, you're using seconds of a minute. Okay, let's have a little quiz, see how you guys do. Okay, if I am steering a compass course across the Atlantic, it could be across Table Bay, doesn't really make much difference, and I am steering what? A course over ground, a heading, both, or I'm just lost and going east. What am I actually doing if I am steering a compass course? The key word being there, compass course. Is it a course over ground, a heading, both? I'm going to choose it here. Okay, the guys, the idea is not to feed the information to each other on the try and let people work it out for themselves before we get an answer on the chat. Okay, so next question. I am steering the same compass course across the Atlantic, across Table Bay, wherever I am, but my navigator has accounted for certain drift. And the wind, hang on, I've gone one too far. I've gone two, sorry, one too far. I'm steering the same compass course, but my navigator has accounted for certain drift. So he's worked out that the current's going one way and we want to make an adjustment for that. Am I doing a course over ground? Am I doing a heading? Both, or I'm just lost going east again. I'm steering the same compass course. What am I doing? Course over ground or heading are the two really. See, this is where people get slightly confused. Okay, so note the word compass course again. Lastly, okay, I'm steering a compass course across the Atlantic, but my navigator is accounted for set and drift, and the wind picks up from the beam. What will change? What will change to the boat? Your heading and your compass course are still remaining the same, but your boat will do what? It'll change my course over ground because I've got the wind blowing on the side. It'll change my heading, or both. Okay, remember your compass course is still being held, but now there is another force on your vessel. The wind coming from the side. What's going to change? Yep, looks like the right answers are coming up here. Francois is getting it right. Cornelius is getting it right. Anton's getting it right. Okay, so if we go back to question 1, it's a heading. If you're steering a compass course, it's where your boat is pointing. Okay, that is a heading. So I think most of you got that right. Now, when you have a navigator who has set and drift put into your heading, it is still a heading. You're still steering a compass course. Okay, so it doesn't matter that the navigator has put set and drift in, he's still giving you a compass course to steer. It is still where the boat is pointing, therefore still a heading. However, the moment you have an additional effect on the boat, like in this case, we've got the wind coming from our beam, from our side, it's going to change our course over ground. Our heading will remain the same. We're pointing in the same direction, but because we've got a new force from the side, it'll change the course over ground. Okay, so that depicts the difference between where I'm pointing or heading and what my course over ground is. Okay, so we can ask questions and what have you about that later, but moving on, standard navigational terms. Okay, we've been through heading and course over ground. First two, we've been through speed and speed over ground, often referred to cog and sog, just that you know. So if somebody says, what's our cog and sog? They're talking about course over ground, speed over ground. We spoke about what our position is, latitude and longitude. Okay. Now, let's look at other terms. Now, we're talking about charts to start with. Charts. All marine maps are called charts. Please, guys, don't call them maps on board. They are called charts. You don't call land maps charts. You call marine maps charts, and they are written charts specifically for navigational use. We don't use land maps for charts. If you look at the picture here, it's a 3D representation of what a chart gives you. Note the land is just pretty flat, and then you've got drop downs, contours, giving you depth information. Okay, it's specific for the marine environment. So it tells you if I'm sitting here where my mouse is, I can't cut the corner here to go into this harbor. It tells me I must go all the way around like that in a 3D representation to make sure I've got deep enough water the whole way. Also, guys, please note, okay, the color schemes. They are dependent on who prints the chart. Charts are printed by government authorities the world over. Note that this one has land as green, drying areas as yellow. Okay. This one has land as yellow and drying areas as green. Not all charts have the same colors. Please, guys, make sure you know what your chart is representing. However, all charts will have a compass rose like this. They'll have a compass rose of some description that'll look something like this. It'll detail what the magnetic variation is on that area of the chart. Many compass charts will have more than one compass rose because the magnetic variation will change on that area of the chart. So if you look at the West Coast chart from here up to Mykonos or to Longitude, I think it's got 2, maybe 3 compass roses on it for the changes on the magnetic variation. However, the main compass rose will always point to the top of the chart, and that's north. So you'll notice that our Latin long, there's our latitude, there's our longitude, will always point to the top of the chart, the same as the compass rose. That is your true. The word true being optimum here. It points to the top of the chart. Okay, so whenever we're drawing on a chart, whether it is a historical course or a bearing that we've taken, we always draw true on a chart. Okay, so whether it's exactly what we've done or what we plan to do, from A to B, from B to C, from C to D, is always our true course. We can write magnetic bits and pieces around it, but the lines we draw on the chart are true. The red is your true course. In this case, the yellow is the current or wind effect, and the green is where we were heading. So that's where our boat was pointing, but we actually traveled along the line of the red, which is our true course. Course over ground, in other words. So understanding heading versus course over ground is quite important to try and get the idea of true versus heading versus any external influence in the yellow. Okay. Keeping accurate records is essential for good navigation. So if you record your A to B, B to C, C to D, you can give yourself a true course. Record the position at A, record position at B. Draw a line between 2. That's your true course. B to C, true course. Gives you distance as well. So talking about distance and speed, the knot. Okay, what is the knot? And look at a nice little picture here. Historically, we would literally drop a line over the back of a vessel, drag it for a certain amount of time, count the amount of knots that drop out, and that will be our boat speed. So we have a little plate here, drop that over the side, half a knot, 1 knot, 2 knots, half. Note that the half used to have a little loop in it. It's a piece of history you don't need to worry about, but there we go. So there's your half knot looped, 2 half knot, 4, so on and so forth. So that's how we used to record boat speed. You can see it sort of dangling out the back here of a nice old schooner. We don't use that anymore. The only thing left to this practice is the word the knot. So that's where knots come from, the word knots. What really is a knot? It's basically a nautical mile per hour. Note the word I'm using, nautical, each time. A nautical mile is quite different to a statute mile. So when you climb onto a motorway in England and it says 12 miles to go, it has nothing to do with a nautical mile. A nautical mile, okay, is 1 minute. So basically, if you look at a nautical mile, it is 1 minute, and note the word latitude. Okay, so a nautical mile is actually derived from the size of the Earth, broken up into 90 minutes, 90 degrees north, 90 degrees south. Each one of those degrees is broken up into 60 minutes. each one of those 60 minutes is 1 nautical mile. So a nautical mile is derived from the size of the Earth, nothing else. Okay? Therefore, a knot is equal to a nautical mile an hour. So we still refer to it as knots from our historical way, but it basically means 1 nautical mile per hour. Please, guys, remember I said to you guys that the longitude gets narrower and narrower and narrower and narrower as we go towards the poles. We can't use that for a nautical mile because obviously it's changing as we go north. Must be latitude, which is even. It's even the whole time. You'll note here on the little cutout that I've got, that distance is different to that distance. Okay? Because this is not on the equator. The equator is the only time that they match. So there's your minutes, making up 1 nautical mile, and there's your tenths. Okay? So if we take 60 minutes to cover 1 nautical mile, we're doing 1 knot. So if we take 1 minute, and it takes us 60 minutes to do it, we're doing 1 knot. Obviously, it takes us 30 minutes, we're doing 2, so on and so forth. So if we're doing a boat speed of 10 knots, it's going to take us 6 minutes to cover a mile. Time distance calculations, very basic ones. But we refer to that as our speed in knots. So 10 knots, it's going to take us 6 minutes to do a nautical mile. Pretty basic time distance calculations. You can use the 10% rule if you want to do it that way. 10% of. Okay, and a nautical mile, and I've got a window up here, and I'm not sure whether you can see it or not. It is, I'll leave that mouse alone and see if it appears. It seems to be on my screen. 1 nautical mile is equal to 1,852 meters. Okay. So that's what a nautical mile equates to in meters, 1,852. I'll try and wait for this thing. When it disappears, you can see it again. Okay, so therefore, a cable, and you probably heard people say a cable before. A cable is 10% of a mile, okay, which is our little pieces that we split up. Remember, we did a tenth, we did our minutes into tenths. So 1/10 of nautical mile is a cable. So therefore, each one of these makes up 1 cable. 10 cables makes up a nautical mile. So therefore, a cable is 18.52 meters, because obviously a mile is 1,852 meters. So what is a cable equals? If we look at our degrees, minutes, and second degrees, minutes, and decimal, 1 decimal is 1 cable. So there we go. 1 little cable there is 1 decimal of a latitude. Let's try a couple of quiz questions. Can I use the London A to Z to navigate up and down the Thames? No, yes, you can do it with caution if I'm staying next to the shore. I don't know if everybody knows what the London A to Z is, but it's basically a road map of London. Okay. Next one. Does my chart compass rose point to true north? Chart dependent? Always, never. No, it points to magnetic north. So my compass rose. Top of the compass rose, the main thing, does it point to true north? Not talking about the little rings on the inside and all the other information. The main compass rose. Does it point to true north? Not all the additional rings on the inside and all the extra bits of information, which we will be going through, by the way, in a later stage. Let's have a look and see some of these answers look like. Yep, getting some nice answers there. And then lastly, a knot is 1832 kilometers, 1.852 kilometers, 1.582. See if you guys can remember the number. A, B, C, or D. I've made them nice and confusing to see if anyone remembers them. Mans has got it. Cornelius has got it. Chris has got it. Anton's got it. Michael's just written it out. It's easier. Yeah, we seem to be getting the right answer there. Okay, so no, it is not a good idea to navigate the Thames. Especially the Thames is a really bad idea, actually, because there are sandbanks and there are buoys and there are all sorts of things that will not be on a land-based London A to Z map. So even with caution is not a good idea, because there will be a lot in the water that you won't see and it won't be on any sort of land-based map. Yes, my compass rose will always point to true north. The inside information is irrelevant to true north. The compass rose will always point to true north. And it's 1.852 kilometers to a nautical mile. So therefore your knot is based on 1.852. It's a really obscure number, but as I said, it is because it is from degrees, minutes, and decimals of a minute. Okay, so 20 minutes for some talking up time. Okay, just it gives a nice general idea of what we're talking about when we're talking about cog, SOG. So if we're talking about cog and SOG, if we're talking about heading, if we're talking about the actual boat speed, it gives you a nice general idea. Theory courses, if you do a sailing course, your theory courses go heavily into navigation. So understanding this basic theory will actually get you a step forward. And don't get flustered, guys. I know it looks like a lot of numbers and a lot of stuff to start with. Now, it'll start making perfect sense once you start using it. But if you are going to start using it for navigation, the app I use on my phone is called Navionics. Okay. Very late people coming in now. And then if you have any questions, and I'm talking about marine questions, not just basic questions, or courses questions if you're interested and you need to know some stuff about the courses that can be done, give me a shout on either wavysailing@gmail.com, or there's my phone number. I've got no problem with an SMS or a WhatsApp or something. But guys, please keep them relevant. You know, can I sail across here and do this really doesn't help me much. Sort of relevant to the teaching or wanting to know about courses and things that I can help you with. And give me a couple of hours to answer them. I might not answer them immediately, especially if I'm at sea. So don't expect an answer immediately, but I'm more than happy to help. Okay. I think what we'll do is just hold you on mute for a second, just chat about next week. We're going to talk about navigational charts and publications. Okay, there are hundreds of marine publications, so we're going to highlight some of them, not all of them. Okay, firstly, obviously charts. What information is on a chart? Okay, so if you can, during the course of the week, try and have a look at a chart, maybe online, maybe if you've got one at home. Start looking at the little bits and pieces. You can see on this photograph, we spoke about WGS 84. There it is on this chart in front of you. Okay, that's one of the things we know about. The other things we know about was the compass rose. So we'll go into more detail there. Okay, and then the representation of distance on a chart. How do we represent distance on a chart? Now we know that a nautical mile is 1 minute of latitude. How do we represent it? Then we'll talk about actual publications, tide tables, sailing directions, maritime radio procedures, list of lights and signals, etc., etc., etc. The publications that should be on vessels that you sail on, and then we'll talk about chart correction. What happens when a chart starts going out of date? Where do we get corrections from? What do they look like on a chart so that you could recognize chart corrections that are made? Okay, so let's unmute, and I'm just going to try and get my screen to show everybody. Anybody got any questions? Please, guys, feel free. And we've got nice timing here, sort of 15 minutes per question. Anybody want to answer any questions? Looking at faces, a lot of very blank faces. Was that a particularly boring one?
David?
Yeah.
Tony.
Hi, Tony.
Sorry, I lost the comms a little bit there and I had to reboot in. It has never been very clear to me why we have longitude recorded as two digits, 33 degrees, and latitude 018. Why not continuity? Why not 033018?
Okay, Tony, I'm going to flick back on the presentation if you don't mind.
Thank you. Sorry, I lost a bit there.
If you lost, no problem, because well, that's why we've got question time, that sort of thing.
Yeah.
Okay, so there's your latitude. We start in the middle of the planet at 0 degrees on the equator.
Yeah.
And we go to the North Pole, either side, from 0 to 90 degrees. So it only goes as far as 90, or to the South Pole, 0 to 90 degrees. So it will never get higher than 90 degrees. Therefore, it'll always remain in 2 digits.
Yeah, got it.
Whereas longitude starts at the prime meridian or GMT and goes all the way around to the international date line and all the way around to the international date line west or east at 180 degrees opposite. So therefore 3 digits.
Thanks. It's always obvious when you figure it out, when you're told. Thanks.
Okay, so that makes sense to you. Great.
Yeah, good.
Okay.
Dave?
Yeah.
So when you guys go on a race, do you actually take charts with, or you go fully digital?
It often depends on what the race instructions require. If 9 times out of 10, if you go fully digital, you're required to carry 3 independent sources of navigation, which means if you're going electronically, you need 3 independent battery sources for it. And not all boats carry all 3 independent sources of battery for electronics. I personally like to carry paper. I've had my boat hit a couple of times by lightning and lost electrics. And so paper is quite useful after you lose all your electrics. Did that answer your question?
Yes, it does.
Yeah, great. I'm trying to find, does anybody know how I get everybody's pictures back? There we go. Okay, so yeah, it does, but 90% of the time you'll be required to carry one or the other or a certain number, and it'll be in the race instructions. For cruising, I would suggest having paper, and there are a number of sites cruising clubs where the guys have said, I've cruised this part of the ocean, I'm not going to use these charts again, let's pass them on to the next cruiser. So the charts get recycled that way as well.
David, do you do a refresher course on astronavigation?
I teach astronavigation, and I'll teach celestial bodies and things, but not during these next couple of weeks. It's the actual course I teach is a 5-day in the classroom non-stop. So It's 5 days, 9 to 5 in a classroom to do astral navigation. So obviously I can't do it in a 1 hour session, you know, in the evening.
Okay, thanks.
For those who don't know, celestial navigation is using a sextant in the stars, sun and moon. And it's quite fun to do. Okay, any other questions? Very quiet tonight.
Somebody raised a point earlier. The decimal, so 1 decimal of a minute, is that 18 meters or is it 182 meters?
Is my maths incorrect? 10% of,
Would be
what's
182
10%?
meters.
Yeah, what's 10% of 1,852? Is that 10%? Is it 18 or 180? I can't, mathematically, I think it would be 180. Sorry. Okay. Did I put my decimal point in the wrong place? Okay. Well, 10% of a mile is a cable. That's what we're looking for. In other words, a mile will be 1.852 kilometers or 1,852 meters. By the way, guys, that 1,852 meters is a favorite question of examiners. So if you're doing a sailing course, that's a favorite question. How long is a mile? How long is a nautical mile? Because it comes up in both navigation and in coal rigs. So there's 2 times you're supposed to know it.
David, thanks very much. It's absolutely brilliant. Look forward to seeing it develop further, eh?
Yeah, well, I mean, it's, as I say, it's not a sailing course, as sailing courses as
Awesome.
such,
That's good stuff.
because I can't put it all in.
Yeah,
If you just take the basic day skipper course, it's a week long, 5 days in the classroom all day, plus 6th day with an exam. We obviously can't fit that in on 1 hour sessions. That's it.
Yeah.
But it should give a basic bit of knowledge for the guys to go out, and next time Rhett goes the wrong way on a course, you can say to him, where are you going? What's your heading versus your course over ground?
No, that's great. Thanks very much.
It's a pleasure, guys.
Well, thank you very much.
Gives us something to do on a Wednesday night when we can't go to the club anyway.
Cheers.
David, this is Peter. Can you hear me?
Yeah, go Peter.
I'm on the paths there. I haven't got a picture up yet. I was only invited to session 3. Are these sessions available? In other words, the first 2, are they available?
They are. I believe Kerry might be able to answer that.
Hi.
Oh, okay.
Not at the moment. They will be going up in time. We're just going to collate them all and put them onto our YouTube channel with password protection, so that it's not open to everybody, and it's specifically for members only. So in time, Pete Sherlock will put that up.
Okay, perfect. Thank you.
And your pleasure.
David, I've got one question before you go.
Yeah, sure.
So that you've had a question about celestial navigation. I just want to ask you whether you think it's still relevant to learn how to do it. You know, the first time I crossed the Atlantic, we, of course, you had to do it. You know, it's the only way to get there. But
Carl will be showing both our ages now.
Yeah, well, I tell you what, I looked at your attendees, and I think I'm definitely, without any doubt, the oldest one. But just to get back to the point, you know, I'm just wondering about the relevance of it, because we, you know, for instance, the safety things for doing a rear race these days, do you still have to have anything except a spare GPS or not?
Carl, there's a big difference between doing a race and cruising on your own. I carry a sextant anyway. I have electronic tables on my phone and various other places. And I think it's a really, really good idea. As I say, I have lost electrics in the past. and I could get a position fix, and I did get a position fix from my sextant. On a race, you tend to have a lot more boats around you. It's well organized, and everybody knows where you are. If you're just cruising on your own and you're off on your way to the Caribbean, all on your lonesome, and there may be one other, maybe two other boats out there doing a similar trip, 1,000 miles ahead, 1,000 miles behind, and you lose your power there, having a sextant and having the knowledge on how to use it is a worthwhile thing, simply because you can then navigate your way at least to the nearest port where you can use visual navigation. You know, if you're out there with a fleet, you know, the chances are there's somebody within range that can come and give you assistance. And then you can follow them in or something like that. If you're out there on your own, being able to get yourself home on your own is, yeah, I think it's a useful skill, and or could be very, very helpful if you do lose your electrics. And, you know, just to make a point, boat electrics are not infallible. In fact, any electrics near salt water, and people who have sailed with me on the last Rio I did, we literally had to sort of half rebuild the motor on the way, and we ended up working with the solar panel, desperately just trying to keep the last of the electrics going to get into Rio. And the last bit of the navigation we did there was with a cell phone and not running laptops and that sort of thing, because we didn't have power. So it might have got down to using a sextant had we been further offshore.
Yeah, but you know, you could also argue that if you've got a small little GPS in your back pocket, you know, or you take one and a couple of extra batteries, you know, then you don't need a sextant. And
yeah, you could argue that until you're hit by lightning, and then all your batteries are cooked. And it has happened.
Yeah.
Lightning, because of the amount of current that runs through a boat, unless your backup GPS is in a Faraday's cage with its batteries, those batteries will cook as well, just because of the amount of current that comes down with it. We've literally had digital watches pop on people's arms.
Thank you very much.
It's Peter here again. I would second Dave's comments. I've been in the electronics game all my life, working career, and you only need to be caught out there once with a total electronic failure. Then you say, I should have done that course. I should have known what to do. When you're caught in the middle of nowhere and you have no idea where to go to, you would wish that you've done it.
And the sextant doesn't take up much space.
Thema angeschnitten.
Okay, guys.
Thank you very much.
Yeah. Any other queries, questions?
David, it's
officially we've got 4 minutes left.
David?
Yeah.
Finally, de Villiers' question. I've been looking at celestial navigation. Sextants are quite expensive, but I noticed that there are some plastic models available as well as a backup sextant, as a backup way of navigating. Would you consider it worth the while to buy a reasonably good quality sextant in plastic and practice to do celestial navigation with that as a backup only?
Quite honestly, I teach on the plastic ones, and they're perfectly adequate to give you a position. The really expensive, fancy ones, yeah, they give you lovely readings, but depending on how often you use them, Fani, and depending on how accurate you are with your readings, that's going to be more of an error than the sextant itself, I would have thought. Using a sextant is not the easiest thing in the world, and getting an accurate reading with it is not terribly easy. So I teach with the plastic ones, and I find them perfectly adequate. You can get yourself within even 20 miles, 30 miles. That's going to give you a good enough position if you're in the middle of the Atlantic.
Thank you. I just wanted to confirm that, because that would be my primary requirement, is to get near enough to land so that I can from there do piloting. Precisely.
I mean, if you're coming across the Atlantic and you're trying to reach Cape Town, and you 50 miles out, well, it doesn't matter. You can see the land and you can see where you are and start doing coastal navigation to get yourself in.
Great. Thank you.
I'd hope you'd be better than 50 miles off with a sextant after you've done a course, though.
Sure. Yes, sure.
Thank you very much. Very much appreciated, eh?
No, it's an absolute pleasure, guys.
Dave, thank you, man. That was great. We'll see you next week.
Yep.
Thank you.
Thank you,
Thanks,
David.
Greg.
Thanks, David.
I want to hear somebody one day turn around and say, oh, I had to tell my skipper that he had the wrong heading or he was going on the wrong course over ground. I think that would be very amusing. And that doesn't mean you, Kath.
See you later, man.
Waving when I end the recording.
Yep, go for it, Kerry.